Here we are discussing the IIT Mains Entrance Examination question paper. The examination was held on 6th April, that is last Sunday. By videographing this lecture, our aim is to give as many students as possible the idea that we are conveying to our students. Here we are giving solutions to all the 90 problems that they are asked in the last examination. And we can proudly say that all the questions that we have seen in this question paper are one way or other appeared in our study material. And no new concept. After going through our study material, you won't be able to see any new concept that was asked in the last examination. So, if you go through the study material and the method that we are following here, we are sure that getting a good score in IIT Mains examination is possible for anyone who is going through this method. Now, we will discuss the questions one by one. The first question is x equal to 4 raised to n minus 3n minus 1, where n is an element of n, y equal to 9 into n minus 1, where n is an element of capital N, where n is the set of natural numbers, then x union y is equal to. The method of doing this is, we have to identify the sets x and y. Identifying the sets means, what are the elements of this set that we have to identify. See, to get the set x, we give n equal to 1, 2, 3, etc. So that we are getting the first element as 4 raised to 0 minus 3 into 0 minus 1, namely 0, then 9, then while giving 3, it is going to be 54, 243, etc. And you note that here we are having few multiples of 9, 0, 9, 54, 243. Now, while we see the set y, while we give n equal to 1, we are going to have 0. While giving n equal to 1, we are going to have 9, 18, 27, like that. And you can see that all multiples of 9 are included in the set y. So, definitely we have x is contained in y. So that we will have x union y equal to y. The next question, question number 2. It will be appeared as question number 62 in your question paper. This is second question in mathematics. If z is a complex number such that mod z greater than or equal to 2, then the minimum value of mod z plus 1 by 2. The easiest way to get the answer is using the idea of geometry. That is, mod z greater than or equal to 2 means it is the mod z equal to 2 means it is a circle with center origin and radius 2 units. And the minimum value of z plus 1 by 2 can be obtained by z equal to minus 1 by 2 means this is the point. The minimum distance means it is going to be, first of all, mod z greater than or equal to 2 means it is the exterior of the circle and on the circle. The set of all points on the circle and exterior of the circle is the equation represented by mod z greater than or equal to 2. The minimum value of mod z plus 1 by 2 is nothing but the distance between these 2 points. So, this is minus 2. The distance between them is going to be 3 by 2. Here in your option, the value exactly 3 by 2 is not given. So, from the available option, you have to choose lies in the interval 1, 2. That is the correct option from the available one. Okay? The exact value mod set plus 1 by 2 will have exact value 3 by 2. It lies between 1 and 2. A is an element of R. That means A is a real number, and the equation minus 3x minus greatest integer function x square plus 2 into x minus greatest integer function x plus a square equal to 0 has no integral solution. Then all possible values of a lie in the interval. First of all, you should know what is x minus greatest integer function x. Suppose we have the value 2.5. You know its greatest integer function value is going to be 2. So, if you are finding x minus greatest integer function x, in the case of x equal to 2.5, this value will be 0.5. This value will be 0.5. So, in all the cases, while we are finding x minus greatest integer function, the value is going to be one lying in the interval 0 and 1. But it can't be 0 because if x equal to if x minus x greatest integer function x equal to 0, then x has to be an integer, and it is given that it has no integral solution. So, the value is supposed to lie between 0 and 1. We are considering calling this as x inside the curly bracket. Let x inside the curly bracket be equal to x minus greatest integer function x. Then we will be able to see that it is possible for us to write the given quadratic equation as minus 3 into x minus greatest integer function x square, like that. It is possible for us to write this as minus 3. This is actually integral part of decimal part of x, 3x square plus 2 into x plus a square equal to 0. It's a quadratic equation. So, to solve this, what we do is, this is same as saying 3x square minus 2x minus a square equal to 0. We can have x as 2 plus or minus root of b square minus 4ac divided by 2u. Again, this minus part we need not have to bother. So, it is going to be 2 plus, we can take 4 out, 2 into root of 1 plus 3a square divided by 6, and is equal to 1 plus root of 1 plus 3a square divided by 3. As I told you, the decimal part of x, namely x, has to lie between 0 and 1. It has to lie between 0 and 1. So, we have 1 plus root of 1 plus 3a square divided by 3 is less than 1. So, we have root of 1 plus 3a square is 1 plus root of 1 plus 3a square is less than 3, and from here we can have 1 plus 3a square, this 1 will go to the other side. So, 2 whose square is going to be 4. So, we will have a square is less than 1, A square is less than 1. That means A will lie in the interval -1, 0, or A will lie in the interval 0 and 1. A will lie in the interval either -1, 0 or 0, 1, which is from the available option, the answer is 3. A square less than 1 means A square -1 less than 0. A will lie in the interval -1 and 1, excluding 0. Why we are excluding 0? Why we are excluding 0? If A equal to 0, what happens? If A equal to 0, x minus greatest integer function x, that means the decimal part of x is going to be 0, is going to be a solution. If this is 0, x will be an integer, and it is given that it has no integral solution. So that is why A can't be 0. So the option is -1 to 1, in which we are avoiding the point 0. Let alpha and beta be the roots of the equation px square plus qx plus r equal to 0, p not equal to 0, p, q, r are in AP, and we have one more condition that 1 by alpha plus 1 by beta equal to 4. Then you are asked to determine the value of mod alpha minus beta. You know the expression for alpha plus beta and alpha into beta if you are given a quadratic equation. But there is an expression for the difference of the roots of the quadratic equation also. Suppose you have the quadratic equation ax square plus bx plus c equal to 0. You know alpha plus beta is minus b by a and alpha into beta is c by a. And what about alpha minus beta? Of course, mod alpha minus beta. It can be obtained by root of alpha plus beta whole square minus 4 alpha beta. That on simplification, we have an expression that root of b square minus 4ac divided by mod a. We will make use of this result while doing this problem. Mod alpha minus beta is root of b square minus 4ac divided by mod a, right? Now, we have here alpha and beta are the roots of the equation, so that we can have alpha plus beta equal to minus q by p, and alpha into beta equal to, what about alpha into beta? R by p. Also given that 1 by alpha plus 1 by beta equal to 4 implies alpha plus beta equal to 4 alpha beta. Alpha plus beta equal to 4 alpha beta. While substituting, we have, it is going to be minus q by p equal to r by p, or from here we can say 4 times r by p. We can have q equal to 4r. Q equal to 4r. Q equal to minus 4r. Now, we have given one more condition, namely P, Q, R are in AP. If P, Q, R are in AP, we can have P, Q, R are in AP will imply 2 times the middle term equal to first plus last. 2Q equal to P plus R. We already have Q equal to minus 4R. Q can be replaced by minus 4R equal to P plus R, will give us P equal to minus 9R. Okay? P equal to minus 9R. Now, the given quadratic equation, what is that? Px square plus qx plus r equal to 0 becomes, quadratic equation becomes P, that is minus 9r x square plus, what about q? We have found the value of q as minus 4r x plus r equal to 0. So, it is possible for us to rewrite this equation as 9 x square plus 4x plus 1 equal to 0, plus 1 equal to 0. Now, what we are asked to determine? The difference of the roots. The difference of the roots can be obtained by the formula that I have told you, root of b square minus 4ac divided by mod a. What is that? Root of this is plus 1, sorry, mod a 9. So, it is 52. Root 52 is nothing but 2 root 13 divided by 9 is the required answer. 2 root 13 divided by 9 is the required answer. You are given alpha beta not equal to 0, fn equal to alpha raised to n plus beta raised to n, then this value of we are given a determinant which is equal to some expression is given, then the value of k to be determined. The usual method is, it is possible for us to split this determinant into few other determinants. That means f of n means alpha raised to n plus beta raised to n. This can be splitted as alpha raised to 1 beta raised to 1, that is alpha plus beta, like that we can split. But here we are applying a shortcut, a substitution will work. Suppose we are putting alpha equal to 2 and beta equal to minus 2. We can't choose alpha and beta as zeros. We can't choose alpha as 1 and beta as 1. We can't choose alpha and beta as equal numbers. So, we are choosing numbers in such a way that the given condition should not violate. What will happen if we choose alpha equal to 1? Both left and right side will become 0, we won't be getting anything. Okay? What will happen if we choose alpha equal to beta? The same thing will happen. Okay. So, we are to choose numbers in such a way that our situation should not violate. The given condition should not violate. Yes. Now, if you do so, the given determinant will become 3, while we give alpha 2 and beta minus 2. What happens? This is going to be 1, this is also going to be 1, right? And what will happen to 1 plus f of 2? Alpha raised to n means 2 raised to n, beta raised to n means minus 2 raised to n, plus 1. What will happen? It is going to be 9. So, these diagonal entries, not diagonal entries, these entries are going to be 9s. What about 1 plus f of 3? 1 plus f of 3, it is going to be 1, 1. And this is going to be f1 plus f of 4. You will get it as 33. You will get it as 33. And this is given that this is equal to k into 1 minus alpha, 1 minus 2 square. So, it is going to be 1 minus minus 2, 3 square, 9, alpha minus beta, 4 square, 16. And you can see that the left hand side is going to be on expansion 144. The right hand side is going to be again k into 144. So, that we are getting the value of k as 1. K as 1. The next question, question number 6 is, if A is a 3 by 3 non-singular matrix such that A dash equal to A dash A and B equal to A inverse A dash, then we are asked to determine the value of B B dash. We have B B dash equal to, B can be replaced by A inverse A dash. B dash can be replaced by, what is B dash can be replaced? A inverse A dash whole dash, right? Now, this is again going to be equal to A inverse A dash dash, that is A into A inverse dash. As matrix multiplication is associative, it is not commutative, but it is associative, we can combine this, so that we are getting, this is going to be I. A dash, A inverse dash, A inverse dash, that is again going to be I. So, effectively the answer is I. So, the correct option is 4. The correct option is 4. This is a question from binomial theorem. If the coefficients of x cubed and x raised to 4 in the expansion in powers of x are both 0, then we have to get the values of a and b. For that, what we do is, we have 1 plus ax plus bx squared into 1 minus 2x to the power 18 equal to 1 plus ax plus bx squared into this 1 minus 2x to the power 18 can be expanded. It is going to be equal to 1 plus 18c1 into minus 2x plus 18c2 into minus 2x squared plus 18c3 into minus 2x cube plus 18c4 into minus 2x to the power 4 plus etc. We need only 4 powers of x. So, we have to consider this much terms. Now, we compare the coefficients of x cube and x raised to